So today, this shouldn't take long at all. I say stuff like that, and then, sometimes it's not true. But today, I just want to quick blow through a few examples of how to do compounding continuously. So today is the second, and we're still solving for P, R, and T. The difference between today's lesson and yesterday's is that these notes are only going to contain the continuously compounding. So the formula we're going to use today is going to be the A equals PE to the RT, the PERT formula, right? So for our first example, let's have a final value of $59,800. I didn't choose these numbers for any particular reason. I was just kind of making stuff up. So where these numbers will take us, like, do we leave them as fractions or do we go to decimals? It's a mystery to me as well. So, and then the initial investment would have been 2150. The interest rate is what we don't know. And then the n is, of course, continuous. So n is like infinity, I guess you could say. And then the time will be 35 years. So having said that, again, as a word problem, this would say what interest rate would be required for an investment of 2150 to result in $59,800 after 35 years of continuous compounding. That would be the word problem version of this. So we're going to start by filling in the PERT formula. What's going to go first? 59,800 goes in place of A. Next up. 450. Yep, goes in place of P. And then remember, E is not a variable, right? And then E to the power of what? R35. Yeah, and we're going to go ahead and call that 35R. I know the formula says R times T, but multiplication commutes, and we generally would put the number before the variable. So R35 isn't bad. It's just kind of a little odd. So, all right. So same idea as yesterday. What has to go first before we can actually start solving? Yeah, we got to divide, right? We know that if we have A and P, step one is always going to be to divide A by P. So this is where we grab our calculators for the first time today, and let's take this for a spin. So 59,800 divided by 2150. And I got the kind of decimal that tells me that I probably shouldn't use a decimal. And so at this point in time, I'm going to say that E to the power of 35R equals a fraction, and I'm going to call it 5,980 over 215. I just reduced by taking off a zero. If you wanted to reduce further by dividing again by 5 and stuff, you could. It's just really serves no purpose in a case like this because we're going to put it into a calculator anyways. So even me taking off the zeros didn't really serve a purpose. It was just 2 less buttons I have to type when I type this into my calculator later. So calculator later. Same steps as yesterday. How are we going to get that R down to where we can solve him? What kind of log? Yeah, I would totally use a natural log here. And the reason, again, as we've seen, is when the E is the base, a natural log will create a little bit of a time saver for us. So when you natural log both sides, I don't know if you want to write this part down or not. You might want to hold off a second. But what it would look like is 35R comes down times the natural log of E equals the natural log of our fraction, 5980 over 215. Right? But having taken a quiz on this last week, you're familiar with what I'm about to do. This natural log of E equals 1. So really what I could have and should have done from the get-go was just write it like this, right? Make my life a little bit easier. And then at the end of the day, it just comes down to basic division. So what I'm going to type into my calculator, of course, we just divide both sides by 35, right? And so R will, in its exact state, be the natural log of 5980 over 215, all of that divided by 35. And what this will look like on your calculator, no surprise here, is natural log. Your calculator opens parentheses for you. And we type in 5980 divided by 215. Remember to close those parentheses. And then you just hit divided by 35. There's no need to hit enter at any point during the process. And your calculator will say 0.0950153663. But really, a lot of that is just stuff we don't care about. So what you want to do is move the decimal, bless you, 2 places first to here, and then from where it will be, examine what the second decimal place would be. And the decimal point would, this is my unit of concern right here, the one I'm underlining, right? No, it's not. I'm sorry, I lied to you. It's this one here, the second decimal place. You see? So I know it looks like the fourth decimal place, but after you move it twice, are you with me? Landon, you with me? So what's it going to wind up being? No, it's still not the right place, is it? It's this one. I had it right the first time. I'm losing my marbles. Yeah, so it winds up being that R is approximately equal to 9.50%. So if you had that interest rate for 35 years of compounding continuously, your investment of P would become a value of A, right? Pretty much the same thing as yesterday, just a little bit simpler, actually. I think a little less chaos to deal with. Any questions on that? Okay. Next one, same thing, continuous compounding. Let's do an a final value of 5 grand. I'm just going to take the dollar signs off already. Our initial will be 125. Our rate will be given this time as 10%. Our n is, of course, still continuous, so n is infinity, and the time is the question mark. How is this problem going to be different than the last problem? It's a trick question. It's not going to be, because whether you're solving for r or t, they're both up in that exponent. So we're going to blow through this one super fast because it's going to be, RT. Last time we didn't know r, this time we don't know t. But we're still just going to wind up natural log, pull it down, divide, game over, super quick, right? So when we set this up, it's going to say 5,000 equals 125 times e to the power of what? No, don't you dare say 10t. 0.1 t. Very good. 10% needs to be converted to a decimal before we input it. Remember, it's 10.0%, so the decimal moves twice to become that. And second verse, same as the first. And this division's probably going to feel a little better. Let's verify that. So if we do 5,000 and divide it by 120, oops. Yeah, ooh, that came out really nice. That's just 40, right? So we just get 40. Probably should have done that in my head. I'm a little embarrassed. So we get 40 equals e to the power of 0.1 t. And this will feel pretty similar, huh? I just didn't switch sides this time. Last time I wrote it backwards. This time I just didn't. So if we natural log both sides, we're going to wind up having the natural log of 40 equals what? Say it again. Yeah, just 0.1 t, right? Because the natural log of e would just go away when we drop it, when we log it and drop it. So just make sure you're consistent. You can't natural log on one side and log base 10 on the other side. That does not work, people. Someone tried that on the quiz. It's not possible. So make sure you're consistent with your log applications. And then from here, what we wind up typing into our calculator will just be the natural log of 40 divided by 0.1. Say again? So natural log for 0, close the parentheses, divided by 0.1, and you should get 36.89 is what it comes out to be. So we would say time is approximately 36.89, and you'd want to label this as years. Your answer should always be labeled with either a percent sign if you're solving for rate, a years if you're solving for time, or a dollar sign if you're solving for coinage. Okay. Still smoking through it. Easy peasy, right? Boys, you good?
Ain't good.
Dang good.
Yeah.
That's just good. On this one, we'll have a final value of 12,819. Did you just say, oh, geez?
I did.
Good Lord. And our P is going to be, as you would guess, our question mark. Our interest rate is going to be 7.23%. Our N is, of course, infinity, and the time will be 12 years. All right, setup. Start me out. What do we do first?
Well, that'll make it 19.
Yeah. Equals P times E to the power of 0.723 times 12. Got a lot of questions about this yesterday, so I thought I would stop just and as we put this into our calculator, just pump the brakes a little bit because I'd like for everyone to not ever miss this. Okay? When we type this in, you have to put in these yellow parentheses. Okay? That's really important because otherwise the calculator will only raise e to the power of 0.0723 and then it'll later multiply by 12. It'll do what you tell it to do. So we need to bully it into breaking the order of operations. So maybe getting a little ahead of myself here, but you got it, right? So let's figure out that, remember, this is just when you're solving for P, there's no logging necessary. There's no rooting necessary. It's just a big old division problem. So we're going to essentially just divide both sides by the red thing, right? If I could get the red thing to divide away, then I'm done. We agree. So what gets typed into our calculator is quite simply 12,819 divided by e to the power of, and if your calculator doesn't give you parentheses, you must manually open the set. Of course, if you already multiplied 0.0723 by 12, then you can disregard the parentheses. But if we still need the calculator to do that for us on the way, then we need to tell it, hey, do the yellow parentheses first. And so then inside of those, we're going to type in our 0.0723 times 12. And then by shutting that down, our calculator now knows clearly what we're asking it to do. We're saying, hey, calculator, do that first. Clear? All right, so let's practice. Let's type that in and then I'm done. So 12,819 divided by e to the power of, like mine doesn't give me parentheses when I do e to the power of. I don't know if yours does, like a TI-30. It doesn't. If it does, great. If it doesn't, add it in. And then in those parentheses, I'm going to type in my 0.0723 times 12. I'm going to close those parentheses down. And just, give it the sniff test and ask yourself, does this answer seem reasonable? So according to us, the principal investment would have had to be approximately $5,383.44. And that passes the sniff test for sure. In our minds, I don't know if you were on the same page as me, but when I looked at the problem, I thought it's going to be somewhere around $3, $4, $5, $6, $7,000, something like that. Like you do enough of these and you start to probably get better at estimating what they are, but we kind of knew the pocket that it had to be in, and that fits pretty nicely in there. Any questions? At this point, you now know how to do every single problem on that packet. So what I'm going to ask of you is the rest of the day today, please work, work, work. Tuesday, when we come back from our 4-day weekend, we'll probably have another work day. So I need you to use your time well today. Boys, we're not talking about trailers and lumber and parts that we bought to fix radiators and stuff like that. We're just going to work.
I really want to talk about water.
I know. What a great day to talk about water pumps, but let's go ahead and do that later. Today, we're going to spend the next 28 minutes just working on math problems. Huh? Sweet.
Can I have a? Yeah, this will have